The key information for what we're doing today is our transformations that we talked about yesterday. Okay, we said that the vertical translation means it moves us up and down, and that is dictated to us by whatever were added or subtracted at the end of your absolute value, right? Outside the absolute values. That moves us up and down. Whatever is inside the absolute value, added or subtracted, moves us left and right. But remember, what's inside moves us left and right, but it's opposite what it says. That's why we say x is hexed. And whatever is outside moves us up and down, and it does exactly what it says. Y is y's. Okay? So what's inside, it says it does opposite. What's outside, it stays the same. We also said that the value out in front, A, there were a few problems from yesterday's homework that had a number out in front other than 1. That number, if it's greater than 1, gives us a skinny graph. If it's between 0 and 1, it gives us a fat graph. Also, I said yesterday, if A is negative, our graph opens down. Okay? Those items are going to become very important for us to know for today's work. Now, I'm going to show you 2 shortcuts for graphing absolute value functions. Okay? The first one is still plotting points. And I want to show you that by looking at the problem we did yesterday here at the bottom. Okay, so this problem, if I'm going to do this again by plotting points, I want to first start from my vertex. Well, we said yesterday when we worked this problem that the parent function starts with a vertex at 0, 0. But in this problem, they have us moving to the left 2. Remember, x is hexed. Left 2, up 3. So by moving left 2 up 3, our new vertex is at negative 2, 3. Okay, that's the new vertex of our problem. Well, then from there, if I want to plot points, just put that vertex in the middle. And so then we want to pick x values to the right of our vertex, so like negative 1 and 0, and to the left of our vertex, like negative 3, negative 4. Because when you put the vertex in the middle, you're then going to see both sides of your v. You're not going to have to search for the vertex like you did yesterday. And so now we can plug in, well, I'm just going to steal some values from yesterday's work. So when x is 0, y is 5. When x is negative 1, y is 4. When x is negative 3, y is 4. And if we plug negative 4 into the equation, negative 4 plus 2 is negative 2. The absolute value of negative 2 is positive 2, and 2 plus 3 is 5. So, plotting those points, we again would see that at 0, 5, we're there. Negative 1, 4 is there. Our vertex is at negative 2, 3. Negative 3, 4 is there. And negative 4, 5 is there. It would give us the points we need to graph our function. Questions?
Can you do another example?
Most definitely. Most definitely we'll do another example. So let's try the one right next to it. Okay. Again, I want to graph this by plotting points, but in order to plot my points, I first want to find my vertex. So the vertex comes from the shift. We have a horizontal shift moving us to the right 2. So that means our x-coordinate is a positive 2. We have a vertical shift that moves us up 1. So that means our y-coordinate of our vertex is a positive 1. So the parent function has a vertex at 0, 0, but our function has a vertex at right 2, up 1. Okay, so we just move our vertex to the coordinate 2, 1. Questions on finding that part? Because that's important regardless what shortcut you use. All right, so we have our vertex. Well, now we need to plot points. And for plotting points, we put our vertex in the middle. So we then need 2 points to the right of our vertex. So we need x values to the right of 2. 3 and 4. Going to the right. Okay, we now need 2 x values to the left of 2. 1 and 0. So we now plug those in. So 0 minus 2 is negative 2. Absolute value of negative 2. 2 plus 1, 3. Please finish that list for me. Okay, we should all have those done by now. So what are our y values? We have 3, then what? 2, 1, 2, and 3. Okay, so just like yesterday, let's go ahead and plot those points. 0, 3, 1, 2, 2, 1, 3, 2, and 4, 3. So you see, by having the vertex centered in your T-chart, it shows you all the points you need to draw your graph. Questions? Yes, sir.
Well, from the vertex, can you just go up 1 over 1?
We're going to get there. Don't worry about it. All right?
I can't remember that from algebra.
We're going to get there. Any questions? Oh, yep, yes, ma'am.
Okay, so the origin, like the red little red dot, do we have to draw that?
No, you do not have to draw this at all. All right. Let's take a look at backside of your notes here. On the backside of your notes, at the top, it says what the general form for an absolute value function is. Okay? All they're doing is putting all of those shifts that we talked about on the front side of our notes, they're putting them all into one equation. Okay? So we have y equals a times the absolute value of x minus h plus k. The key thing is here, and we've already done it twice now, but your vertex is located at hk. The axis of symmetry, it's the vertical line that passes through your vertex. That's located at x equals h. Okay? Vertical lines always have the equation x equals and then whatever the x-intercept is. Okay, so it's always going to be x equals whatever your h value is, or whatever the x-coordinate of your vertex is. One other thing that we don't have on here, okay, and you hopefully saw it on a couple of problems from your homework, namely 19 and 22 from your homework, you had this, where a was some other number. Right? A was 2, or one problem, A was negative 3/4. But what they don't tell you here that you guys need to know is that A, not only does A tell you if we open up or down or if it's fat or skinny, A is the slope of the right side of our V-shaped graph. Okay? That is important information for us. That helps us graph these real fast. So now, using that, we don't really have to plot points at all. Okay? If you understand this shortcut, and if you understand the transformations on the front side of your notes, you don't have to plot points at all. Because we can find out all the information we need just from the equation. For example, without graphing, what is the vertex and axis of symmetry of our equation? Well, the vertex is going to be located, now remember, x is hexed, y is y's. So, positive 2, positive 4 is our vertex. The axis of symmetry, or AOS, is the line x equals what? 2. It's always what the x-coordinate is of your vertex. Okay? There's our axis of symmetry. Well, now they want us to decide, well, how is this parent function transformed? How do they change the parent function? Well, the parent function has a shift. So since our vertex is at 2, 4, where are we shifting our graph? Careful. We're going to the right 2. Where else? Up 4. We're going to the right 2. We're going up 4. Our graph is going to open up because A is positive. Also, A is 3. So what does that mean about our graph? Is it skinny or fat? Look at the front side of your notes. If A is greater than 1, it's one thing. If it's between 0 and 1, it's something else. This is going to be skinny. So folks, all this information we can figure out by simply looking at that equation. Questions? You've got to be able to do that because the more you learn the stuff we just talked about, how to find your shift, how to find your vertex, A opening up or down, being skinny or fat, that stuff is going to stick with us for the next couple of types of functions we're going to graph. That stuff isn't going to change. So if you learn it now, the stuff we're going to do over the next couple of weeks is going to be that much easier. Okay? So please practice that stuff now. Any questions? Yes, sir?
What does a parent function do?
A parent function is just the simplest form of that function. So the parent function for our graph here is just y equals the absolute value of x. It's the simplest form of that function. Yes, sir?
And the x equals 2, is that just because it's in the absolute value? Or, like, what
Axis of symmetry, x equals 2 is a vertical line. If I graph that line, I go to where x equals 2, and it's a vertical line. Okay? So that is the equation of this line. We had a homework problem like that a couple days ago, where we graphed a vertical line for our homework.
You got the x from the...
And I got the x from my vertex, because my vertex for this particular graph is at 2, 4.
And you don't do anything with 3?
Well, not yet, because we're not graphing yet. Right now, we just wanted to find this information out. Okay? Any other questions? Okay, so let's take a look at an example where we are going to try to graph. Okay, so again, we want to pull information from our equation first. So, where's our vertex? -4, -3. Where's our axis of symmetry? Do I just write -4 or do I write an equation? X equals -4 is the equation. Okay? What is the right side slope? Right side slope is 2. A is the right side slope. That's what it says right above this problem in your notes, right? Is our graph going to open up or down? It's going to open up because A is positive. That is the information we need to graph this guy.
Do you know if it's skinny or fat?
We'll figure that out real quick, but you can probably tell me if it's skinny or fat right now. What's it going to be? It's going to be skinny, yeah. Okay, so let's first graph our vertex at -4, -3. Then I want to draw my axis of symmetry, which is that vertical line, x equals -4. It'll pass right through our vertex. So now, the slope of the right side of our graph is 2. So from our vertex, just count a slope of 2 on the right side. Up 2, right 1. Up 2, right 1, up 2, right 1, so on and so forth. And then remember from yesterday, we talked about the fold of that heart, right? From Valentine's Day when you guys were kids. You fold a heart in half. Well, that's all we're doing here is we're going to fold our graph in half. Every point that's on the right side has to be mirrored to the left side. So think just going up 1, up 2, left 1 from your vertex. Every point needs to be mirrored to the other side. Okay. And then we just need to go ahead and graph our function. Questions? You sure? I'm hoping this is going to be a lot easier than what you had to go through yesterday.
Maybe one more.
We can do one more. Yep. In fact, why don't you let me do one in another form here? I want to show you something else as well. Yesterday we talked about reflections where the negative was on the outside of the absolute values, right? I said that, and then the graph opens down. But there was that other reflection where the negative was on the inside of the absolute value that I said ignore that, right? I want to tell you about how we deal with that right now. Thomas, you had a question quick?
Oh, yeah. So the A1S is going to be opposite whatever, the x plus...
The axis of symmetry is always going to be exactly what your x-coordinate of your vertex is. Every time. Okay, so let's take a look at our next example here. Because notice this next example has a negative x inside the absolute value. Well, the way we want to take care of this is using a rule from algebra that may not have been really forced on you guys. You guys may not have seen this a lot or may not have practiced this a lot, but it is a rule of algebra. And the rule says, now remember we had a rule for square roots where I said the square root of a times b equals the square root of a times the square root of b? Remember we talked about that a lot when we were reducing radicals? Well, same thing goes for absolute values. The absolute value of a times b equals the absolute value of a times the absolute value of b. That rule is true every time. Okay? So what we want to do is we want to use that rule to simplify our equation. I do not want -1 out in front of my x inside the absolute values. So what I need to do is factor out a -1. So I have y equals the absolute value of -1. Oops. Absolute value of -1 times positive x plus 3. And then plus 9. So on the inside, I factored out a -1. Now I want to use the rule to rewrite it. Break it apart into two absolute values. So the absolute value of -1 times the absolute value of x plus 3 plus 9. Well, what's the absolute value of -1? 1. So y equals 1, or we don't need to write the 1, but 1 times the absolute value of x plus 3 plus 9. This is the equation I want to use to graph, because that is now written the way that we're used to seeing it. Questions? No? Cool. So now looking at that equation, where is our vertex? -3, 9. Excellent. Where's our axis of symmetry? X equals -3. It's always the x coordinate of our vertex. And what is the right side slope? 1. A is the right side slope, and A is 1 in this case. So we go ahead and graph. I'm going to graph my axis of symmetry first at x equals -3. Our vertex is at -3, 9. And now the slope of the right side of our graph is 1. So from the vertex, I count up 1, right 1. And I do it a couple more times, give me some more points over there. And now all we need to do is use our property of symmetry to find the points on the other side. So up 1, left 1. And there's our graph. Questions? Are you sure? Okay, then there is one more type of problem that I want to show you guys, which is writing the equation of an absolute value function. Now, the first thing that you need to do for this is to write down the general form. Okay, the general form is at the top of your notes there, and it says y equals a times the absolute value of x minus h plus k. So, looking at that, we need to find certain information. We need to find a, which remember a is the slope of the right side. And we need to find our vertex, which is located at hk. Well, looking at the graph, where's our vertex? -1, 4. Okay, so our vertex is actually located at -1, 4. The slope of the right side. So what we need to do there is find another point on the right side of our graph that falls on a nice crosshair, such as that one right here. So how are you going to find the slope then? So you're counting, right? Yeah, count. That's exactly what I want you to do. Counting your slope, I'm going down 1. So my rise is -1. My run is to the right, 3. So A is -1/3. So all we need to do is plug it into the equation. Y equals -1/3 times the absolute value of x. Now, am I going to say +1 or -1 here? +1, because remember, x is hexed. And then +4 at the end. Questions? Are you sure? Okay, let's try some homework then.